Chapter 8, Section 5, Question 1, Type 1 of 2. The last section of this chapter. How awesome is that? We're going to complete the square. Do you remember back in 8.1, we were completing the square? It was to prepare you for this section right here. Woohoo! All right, here we go. We are not allowed to touch this side of the equation. So we have x squared minus 12x plus a complete the square. We scooch over. Instead of moving it to the other side of the equation, we're going to scooch it over. And if we add something, we must be fair and subtract it because we're all working on the same side. If you remember, back in 8.1, we added something to one side and we added it to the other side, and we did the same thing to both sides. But now we took this one, and when we cross over the equal sign, it is now the opposite. All right, how do we get this little number in the square? Back in 8.1, we took b divided by 2 and squared it. b is negative 12 divided by 2 and squared. Negative 6 squared is 36. We're going to add a 36, and we're also going to subtract a 36. Now, some people combine like terms, and they're like, hey, I got the question back again. Well, yes, but we don't want to get the question back. What we want to do is complete the square. We put those numbers in, and then you do not have to put these little swoopy things. You do not have to put these little swoopy things. I'm just saying, where do your eyeballs look? You look at that. Do you see the perfect square trinomial that we had in 8.1? We're going to factor that as x minus 6, the whole thing squared. Remember back in chapter 5, section 6, when we were doing this, I said you could write it as x minus 6 and x minus 6 in chapter 5 and chapter 6. But the time we got to chapter 7 and chapter 8, you have to write it as this squared. Then, add and subtract. And done. Bam! That is what we're looking for. Why are we looking for that? That will become clear soon. This is all we want to do. How nice! What a quick problem. Don't worry, the next question will be slightly harder. Chapter 8, Section 5, Question 1, Type 2 of 2. Here it is, slightly harder. Oh no, it has a leading negative. Normally we would move it to the other side of the equation, so it would be positive, but you can't do that because we're not allowed to touch this side. That has the function notation there. How do we deal with this? We're going to concentrate right here. So we leave this on the left-hand side. We're going to factor out the negative, but only from the first two, only from the ones that have the x's. That is the important thing. So we're factoring out that negative, changing the sign from negative x squared to positive x squared, from negative 12x to plus 12x, and then we're going to have a plus 3. And we're going to have, of course, our plus box. Now, get ready for it. The one out here is actually going to say plus box also. But wait, Miss Jordan, I thought you said that we in 8.1 had adding to the right and adding to the left, and when we brought it over, one was positive and one was negative. Are you lying to me? No, I am not. Let's take a look. By the distributive property, this is the negative box, and that's the positive box. Does that mean I should distribute? No, don't distribute. Leave that as a positive in here. But just know that that's why it looks like it's two positives, but really that's a negative and this is a positive. This is going to be huge because this is a step towards what's going to happen in your college class, which is going to be yuckier stuff. So we got to get through this. So b, which is 12 divided by 2, the whole thing squared. 6 squared is 36. And again, you do not have to draw these swoopies. This is just so that you keep your eyeballs where you're supposed to. This negative just drops straight on down. This factors as x plus 6, the whole thing squared. A lot of people forget the squared. And then we add this together and we get 39. That is done. Folks, still a very short problem. This is all we're looking for. This is all the college professors are looking for. This is something you're going to have to know. But this part here, where it looks like you did plus 36 and plus 36, that's confusing to a lot of people. But you need these parentheses here, and you need to factor that out, only for the first two. A lot of people factor out from all of them because we've done that so often. But hey, this one just switches over, same as it did with the positive version. Be very careful on this one because about half of your questions will have a negative and the other half will have a positive because we're trying to prepare you better for your college classes. Wow, look at this. Chapter 8, Section 5, questions 1, 2, and 3 mushed together into one big honking question. Why? Because this is really what it's going to look like in your college class. But we, as your loving yet evil math teachers, broke it up into 3 little bite-sized pieces for you for this level of math. Determine whether the parabola opens upward or downward. We learned this back in Chapter 3. We look here. Is it a positive x squared, which makes a happy parabola, or a negative x squared, which makes a sad parabola? So if A is positive, then it makes a happy parabola, which makes a U, for it opens upward. If A is negative, it makes a sad parabola. Real parabolas do not have eyebrows, which makes an N for downward. This is a negative parabola, so it opens downward. I will have a circle 1 on there. Remember that circle 1 is one of the most missed questions on any of my tests because people do not circle 1. I am still waiting for the year when everyone circles 1, preferably the correct one. All right, find the y-intercept. We have been finding the y-intercept since Chapter 3. The way we do that is to find a y-intercept, x will have to equal 0 so we can find the y number. So over here, x has to equal 0. We can plug it in. And find f of 0 is 12. That is the ordered pair 0, 12. That is your y-intercept. Yay. But you might notice that, wait, if I plug in 0 and I plug in 0, 12 is the answer. You are correct. The formula for this is 0 first and the C number second. You could just look at it and write the answer. If you remember this in your college class, that is going to be amazing. It'll help you with so many questions. If you remember this, whether it's upward or downward, there's going to be a bunch of multiple choice questions that you can figure out with just these 2 problems. I actually gave you something like that with multiple choice back in Chapter 5, Section 1. Perhaps preparing you better for college. And this section. Write the equation in vertex form. This is what we've been doing. Writing it in vertex form. The last 2 slides where we were completing the square, that's what we're doing. How do we do that? We're going to underline these first 2 because that's what we're looking at. And we're going to take f of x. You cannot touch that f of x. It has to stay there on the left. Factor out the negative. X squared, change the sign, minus 4x because we changed the sign, but do not factor it out of the plus 12. Remember when we have this negative here, that we're going to have a plus box and a plus box. Normally it's a plus box and a minus box, but because of the distributive property, this is actually a minus box and that's a plus box. Please do not actually distribute that. We're going to use the formula b divided by 2, b divided by 2, the whole thing squared, which is negative 4 divided by 2, the whole thing squared. That will give me a 4 here and a 4 here. Keep the negative in the front, factor that as x minus 2 squared, add and subtract, and you will get 16. This is vertex form, so what is this A? A is negative 1. A is negative 1. It's the same A. H and K are the vertex. So when it says to find the vertex, it wants H and K. Oh, that's neat. And X is going to be equal to the H. Now, let's take a look at this. We've done this before, back in Chapter 5. I can equal 0. That is the axis of symmetry. X is equal to H. Let's take a look. X minus H, X minus the H number. H is 2. H is 2. Now, we want to find the vertex of the parabola. The vertex is h first, k second. H first, k second. H is 2, and k is 16. That's the vertex. It's called vertex form because you can just look at it and write the answer. How lovely! Find the x-intercepts. Find the x-intercepts. I feel like we've been doing this since chapter 5. We've been doing this since chapter 5. We make f of x into 0, and we have negative x squared plus 4x plus 12. But this is negative, so we're going to actually move everything over to the other side, or we can change every sign. Either way works. And we can factor it and solve it. Now, do you think that we're always going to be able to factor it and solve it? No. Right now we can factor it and solve it, but next year you're going to have to use the quadratic equation because there will be yucky answers. So here we go. But wait, they said x-intercepts. The x-intercepts are x first and 0 for y, and x first and 0 for y. Huzzah! And then they want us to graph it. We have a lot of information about this. We know that the vertex is at 2, 16. Take a look at where my x-axis is and my y-axis is. That's because I know that I'm going to have to go to 2, 16, 1, 2, and up 5, 10, 15, 16. That is the vertex. It is a parabola opening downward from there. The y-intercept is at 0, 5, 10, 11, 12. 12 here. The axis of symmetry is at x equals 2. That is an invisible dashy line. Sorry, I'm not using a straight edge. That cuts our parabola in half. And it means that if we know that this point is 2 spaces on the left, there is a corresponding or matching point 2 spaces on the right. How nice. We also know x equals 6 at 6, 0, point. And then we would have the same thing for on the other side at negative 2, 0. Hey, we can get a fairly good parabola. Also, remember something from back in chapter 3. The vertex is here. If you go over 1, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and same thing on the other side. This is how we count to get to each new point. But we have an a of negative 1. So instead of going over 1 and up 1, we're going to go over 1 and down 1. Over 1 and down 1. Same thing on the other side. Instead of going over 2 and up 4, we go over 2 and down 4. 1, 2, and down 1, 2, 3, 4. Hey, over 2 and down 4. It's like we already had them. Instead of going over 1, 2, 3 from your vertex and up 9, we'll go over 3 and down 9. Over 1, 2, 3 and down 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, that's a new point. Nifty. And then you could do the same thing on the other side. 3 on this side, 3 spaces on that side. And then, hey, 4 and 16, and 4 and 16, we have those. And we're going to start here at the top and go, slightly past the edges, arrows at both ends. Slightly past the edges, arrows at both ends. Hey, look at that! That is a beautiful parabola, and that is something that you're going to have in your 121 class, in which case you're going to have to label a lot of things so that you know what all these things are. So, upwards or downwards is downwards. You would have to say, hey, the y-intercept is that. Find the equation in vertex form. Hey, this is the equation in vertex form. And you might have to do equation is that. Find the axis of symmetry. You might have to say, this is the axis. Find the vertex. You might have to say, this is the vertex. Find the x-intercepts. These are the x-intercepts. And last but not least, graph the parabola. Now, question 1 is going to be this. Question 2 will have this, 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 and this. We're actually not going to have the axis of symmetry because I don't know why. Our book doesn't ask for it. I'm teaching this to you because I know that these all go together as a set. When you get to 121, it's really not that much harder. You usually have to find it anyway to find your vertex. So I threw it in there. All right, yay! Chapter 8, Section 5, Question 4. Here we go. Maximum area of a rectangle. Find the area of a rectangle as a polynomial. So we're going to break this up into little steps. So first, from Chapter 5, Section 2, we're going to find, hey, area equals length times width. Area equals the length, x plus 6, times the width, 15 minus x. Area equals 15x minus x squared plus 90 minus 6x. Combine like terms, descending order by degree, negative x squared plus 9x plus 90. And if we had to label, it would be units squared. We don't actually have to label on this one because we just need this formula. So this is step 1. Step 2 is to find the value for x that gives you the maximum area. Do you see that this from chapter 3 is an upside down parabola? It will give you the area of this rectangle. Now, let's look at the area of a rectangle. Those are variables, which means that they can change. So what happens is it can start off at a very skinny parabola that's basically 0. It'll get bigger, and then it'll get smaller again. And that's how it works. And so, hey, it'll be about 0, it'll get bigger, it'll get smaller again as x changes. And what they want to know is, hey, how do you get to that maximum point? The maximum point is called your vertex. Now, let's take a look at that. How do we find this vertex? There are 2 ways. One, you can complete the square. You could complete the square, but it's harder when this is an odd number. So, there's another way, which you could actually use in 8.5, question 1. You're going to find this using step 1. X equals negative b over 2a. That sounds very familiar. We have used x equals negative b plus or minus square root b squared minus 4ac all over 2a. Well, what the heck did that mean? X equals negative b plus or minus. Hey, when you have negative b over 2a and you plus or minus, what you're finding is when it's equal to 0. We don't want it to equal 0. We want the maximum area, not the minimum areas, when the area of the rectangle is 0. So we take away the little plus or minus section. That's how we get that formula. If you understand that, you don't have to remember a new formula. So you're going to get x equals negative b over 2a. Hey, do you remember formula, plug, work, answer? It's still here. Here's the formula. Plug x equals negative 9 over 2 times negative 1. Work x equals negative 9 over negative 2. Answer, x is equal to 9 over 2. I am totally okay with 9 over 2. If it makes you happy, you may also do it as x equals 4.5. That is fine. If it says to label, then you would label it with units. It doesn't often say to label though. All right, all of this work here is for part A. You have to find the formula so that you can plug work and answer into x equals negative b over 2a. Part B says to find the maximum area. Well, how do you find the maximum area? This is the formula for area. This is the x of the maximum area. What do you do with them? You take this and you plug it in. A equals negative x squared plus 9x plus 90. And we can put in 9 over 2 or 4.5. So, hey, 9 over 2 in case you did not change that over. And then, you can pause it, go grab a calculator, do this. And then, oh, wow, that was kind of difficult. Hang on. Do you remember that we can plug in? So you would get the answer that way. But if you remember, the college professors didn't like you guys plugging into this one. They liked you plugging into this one. Let's look at why that is. If I plug in 4.5 plus 6 and 15 minus 4.5, let's take a look. What we're going to get here is 10.5, and what we get here is 10.5. Well, isn't that interesting? They're exactly the same. They're supposed to be. Now, why is that? Remember how I said that we were going to have this as a small one? It's going to get bigger and it's going to get smaller again? If we stop in the middle, what shape is that rectangle? That rectangle is actually a square. Why is that? If I were to take my tea and pour it onto a table, what shape would the tea make on the table? It would probably make something that was about like a circle. This is a rectangle. Which rectangle looks most like a circle? It's a square. This is a geometry concept. Is a square a rectangle? Yes, it is. Is a rectangle necessarily a square? Not always. So it is going to be a square, and these should be the same. If it's not, you've done something horrifyingly wrong. If the area becomes 0, you have done something very wrong. And then you're going to multiply this together. You will get the exact same answer you would have gotten before, which is, and this is an area you definitely have to label that. So hey, all this work for part A, find the value of x. All this work, plug work, answer. For part B, find the maximum area. Be very careful. A lot of students put this in part A, put that in part B, and they don't know where the heck this goes. Make sure you put them in the right areas. This is all part A, and this is part B. Now, big question. What is that maximum point called? That was called our vertex. Oh, neato. So our vertex, that's the x, and that would be the y. I want you to think about this. So I just talked to you about what water knows about area and calculus. Totally not with this problem, but in the event that you were to use this for something like question 1, if you wanted to find the function in vertex form, we know that the leading coefficient is negative. The x is 4.5. If from chapter 5 you push it backwards into the parentheses, it would be x minus 4.5 squared. And that is a plus 110.25. This is what it would look like in vertex form because we know what the x is and we know what the y is. So if you wanted to use all of this kind of work to get your answer for question 1, I would actually allow that. College professors wouldn't, and it wouldn't help you very much for later on, but I would let you do that for question 1 this year. Yay! Here we go, the last question of chapter 8, section 5. Yay! Question 5, here we go. Hey, blah, blah, blah formula. Isn't that nice? If you remember from question 4, we're trying to find out where this negative parabola hits its maximum height. Now I will tell you that some of them are going to reach a minimum because it's going to be a right side up parabola. Either way, we're going to find the vertex. How do we find this vertex point? Step 1, we're going to be x equals negative b over 2a. And then step 2 is we're going to plug it back in. Hey, find the time it takes. We don't have x, we have t. So the time is going to be this first part, but instead of x equals, we're going to have t equals. And then to find the maximum height, also known as the y, we're going to plug it in. Same 2 steps as last time. Yuckier numbers. Ew. So here we go. A, B, C. T equals negative b over 2a. Why did I do that? Why? Because of formula, plug, work, answer. Hey, 4 steps to do this. I don't have a whole lot of room to go down. I'm going to go across. T equals negative 33.32 over 2 times negative 4.9. I don't have room to go down, so I'm going across. By the way, this is very bad behavior if you're in a college class. By the way, over here, 9.8. 9.8 has to do with the gravity coefficient of Earth, which means that this projectile is being fired on Earth. We're then going to take this, by the way, negative and negative will make a positive. Take a moment, put it in your calculator. T is going to equal 3.2. Word problem though, this is T. What is T? T is time, and time is in seconds. 3.2 seconds. If you think about it, that kind of makes sense. It's not going to be how many hours is this projectile in the air, because it doesn't go. It's going to go how many seconds is it in the air to toss something over. Now we're going to plug it in. This doesn't have a little cute little two pieces where it's going to be equal to each other. You are going to have to plug it into that. Now, things to think about. T is equal to 3.2, so this T is 3.2, and also all the other T's are 3.2. A lot of students do not plug in on this side, in which case it's technically wrong. So, make sure all the T's become 3.2. I need to see you actually plugging it in. I do not need you to write the formula, since the formula is right there. So all I need is plug, and frankly this is big enough, it's on the calculator portion. Get a calculator, type the whole thing in. Let's see what you get. We're going to keep the question on the left-hand side. The height at 3.2. That's why we have to have this. The height at whatever time t is this. The height at time 3.2 is this is what I plugged in. The height at 3.2 seconds is this. How do we label the height? H meters. H at this time is given in meters. T is given in seconds. What is this maximum point called? I hope you remember. That maximum point is called the vertex. How do you find the vertex? Use the variable, in this case t equals negative b over 2a, and then you plug it back in. That is an amazing skill to know. You will be using that skill from now through calculus, those of you who are going on